Hello and welcome back to the good stuff that we have been doing. Today in this video, we're going to try to find this beautiful integral. Says the integral from 0 to 1 of dilogarithm of x times dilogarithm of x times log x divided by 1 minus x, and it says it's equals to negative 3 over 10 zeta squared of 2. Now, for definition's sake, the dilogarithm function is defined to be the sum as n runs from 1 to infinity of x to the n all divided by n squared, whereby x is less than or equal to 1, whereby dilogarithm of 1 actually is equals to the sum as n runs from 1 to infinity of 1 over n squared. Where here, notice here that also zeta of 2 is dilogarithm of 1. Zeta of 2 equals dilogarithm of 1. So this is equals to pi squared over 6. Now we are asked to compute this definite integral, and one way to do this is that we need to observe that this dilogarithm function, they have a neat integral representation. For example, now it can be verified that dilogarithm of 2 of x, the dilogarithm of x is equals to negative the integral from 0 to 1 of x log t all divided by 1 minus xt dt. So this is the integral representation of the dilogarithm function. And using this integral representation, we can now tackle this integral, because we can come and say, okay, this whole thing is equal to the integral from 0 to 1 of log x all divided by 1 minus x. Now we are multiplying this by negative the integral from 0 to 1 of x log t all divided by 1 minus xt dt, then dx. So we have not done anything strange though so far. All that we have done is to make use of the integral representation of the dilogarithm function. Now, having this in mind, we can continue as follows. We could come and say, okay, this is equal to the integral from 0 to 1, negative times the integral from 0 to 1 of x log x log t all divided by 1 minus x and then 1 minus xt, then dt dx, where obviously we can switch the order of integration and say this is equals to oops, this pen is not so functional. Oops, yeah, this is equals to negative the integral from 0 to 1 times the integral from 0 to 1 of x, say log x log t all divided by 1 minus x, 1 minus xt times dx dt. Okay, now we will use partial fraction for x all divided by 1 minus x and 1 minus xt, and we claim that this is equals to 1 over 1 minus t times 1 over 1 minus x minus 1 over 1 minus xt. And this is not too hard to prove, because if you multiply the top, you get 1 minus xt minus 1 plus x. So they cancel out and you get a x 1 minus t. So you see that this 1 minus t and 1 minus t, they cancel out, and that simplifies everything. So we could move on like this and say this equal negative the integral from 0 to 1 of 1 over 1, we're going to bring out log t of log t all divided by 1 minus t times the integral from 0 to 1 of log x all divided by 1 minus x, and then minus the integral dx, of course, minus the integral from 0 to 1 of log x all divided by 1 minus xt dx, then dt. Now let's look at the expression that appear here one after the other. For the first one, we will have log x all divided by 1 minus x. Now this is basically equals to negative dilogarithm of 1, because if you switch x, if you exchange x to 1 minus x, you would have the limit to remain unchanged, but you would have a log 1 minus x all divided by x, and this is for the integral from 0 to 1. So you would have this negative times integral from 0 to 1 of log t all divided by 1 minus t times the integral from 0 to 1 of logarithm of 1 minus x all divided by x dx minus, now this is, if you call the integral representation of the logarithm function, this is actually equals to dilogarithm of t over t then dt. Now for this first part right here, this would be, my pen keeps misbehaving here, sorry. Okay, for this first part, oops, the pen is misbehaving now. Okay, sorry about that. For this first part right here, this will be negative the integral from 0 to 1 of log t all divided by 1 minus t times, the first one is negative dilogarithm of 1. Okay, that is what the first one will be equal to, because if you expand the series, if you do, this logarithm series, this is equal, the logarithm of 1 minus x all divided by x actually is equals to 1 over x times the sum as n runs from 1 to infinity of x to the n minus 1 negative x to the n minus 1 over n. Now if you x to the n over n, now if you divide by n, you get n to the n minus 1. Now if you integrate, you're going to get dilogarithm, negative dilogarithm function, so that is why it's equal to negative dilogarithm of 1. And then this part here, this other one here, is plus dilogarithm of t all divided by t then dt. So on the first part you would have this is equal to this will be equal to, now you will have dilogarithm of 2, dilogarithm of 1, which is basically pi square over 2. So you have a zeta of 2 times the integral from 0 to 1 of log t all divided by 1 minus t. Then on this part you will now have minus the integral from 0 to 1 of log t dilogarithm of t all divided by t 1 minus t dt. Now we can do partial fraction for this, and this would be zeta of 2 times the integral from 0 to 1 of logarithm of 1 minus t all divided by t dt. Then you have minus, for this other part you have the integral from 0 to 1, because 1 over t plus 1 over 1 minus t is just 1 over t 1 minus t. So you have the integral from 0 to 1 of log t dilogarithm of t all divided by t dt minus the integral from 0 to 1 of log t dilogarithm of t all divided by 1 minus t, and this is basically equals to I. So this is the t. Now what we could do is to bring I to the left and divide everything by 2. So doing so, you would get this is equals to half of negative zeta square of 2 minus this would be the integral from 0 to 1 of logarithm of t times the trilogarithm of t prime dt. Now this would be negative half of zeta squared of t of 2, then minus, if you do integration by part here, you would get plus, actually you will get a plus the integral from 0 to 1 of that trilogarithm of t over t dt, and this will be negative half of zeta squared of t plus the trilogarithm of 4, the tetralogarithm of t from 0 to 1, which is which would be equals to half of, okay, This will be equal to negative half of zeta square of 2. Then this is then going to be plus zeta of 4. Now zeta of 4 is actually going to be half of zeta squared of negative 2 over 5. I think 2 over 5 here. Let me check. Because zeta of 4 is pi to the 4 over 90. So and zeta of 2, zeta of 4 and zeta of 2 is pi squared over 6. So let me say 1/5 times 1 divided by 36. Okay, 2/5, I think 2/5. Yeah, so zeta of 4 is 2/5 zeta squared of 2. So basically you have negative 1 over 2 zeta squared of 2 plus 2/5 zeta squared of 2. And if you do the math, negative 5 plus 2 is negative 3. So you have negative 3 over 5 zeta squared of 2. I believe that is what we had initially here. Okay, negative 3 over 10 is instead, because that is 5 times 2 is 10. So our work is complete here. So that is that. So thank you for watching, and please just subscribe to the channel. Bye and have a nice day.